We're going to start with some very basic examples, but eventually we want to be able to find the solutions to that equation. In order to do that, we have to learn how to divide polynomials. We begin with x plus 2 goes into 3x plus 6. And when you do this division, you must ask yourself, what do we multiply the first term by to get the other first term? 3. And 3 is a constant. So should I pair it with the 3x or the 6? So it sits right above the 6 because it is a constant. I keep like terms in line with one another. I multiply the 3 back through, and I get 3x plus 6. I subtract, and I get 0. So if you take 3x plus 6 and divide it by x plus 2, you get 3. Well, that's no surprise, because if you just factor out a 3, you can see that your x plus 2s are going to cancel. It goes in exactly 3 times. But they don't always work out like that. Look at B. Does x minus 2 divide into x cubed minus 6x plus 4? Well, we'll try. Anybody know what I have to do after an x to the third? 0x squared. It's a placeholder. Kind of like if you write the number 104, you can't write 14. Otherwise, that's, I guess if you're keeping track of your golf score, that might be good. But if you're looking at your paycheck, that would be bad. So, so I have to put the 0x squared in there for a placeholder in this polynomial. Question is, what do you multiply x by to get x to the third? X squared. Whoop, and I put it above the x squared. So x squared times x is x cubed minus 2x squared. And I subtract. 0x squared minus negative 2x squared. Positive 2x squared minus 6x. I bring down this term because I need a binomial. Okay? So it used to be you'd say, well, I need to bring down another number so that I know, it goes into that how many times. Now it's got to match in terms of kind of size. So we've got x minus 2 and 2x squared minus 6x. They're both binomials. What do you multiply x by to get 2x squared? And that's a x to the first power, so I put it above the 6x because that's the first power. Multiply back through, I get 2x squared minus 4x. It's negative 6x minus negative 4x. Negative 2x. It's okay. X times what is negative 2x? Negative 2, that's a constant, sits over the 4. Get negative 2x plus 4. I subtract, and I get 0. So did it divide evenly? It did. Now, I'm going to show you something that needs to click now. Raise your hand if you remember doing some division before the polynomial. Okay, good. But we're going to see it through a little bit more and a little bit more in depth. And here's the piece you need to understand. This factors. It factors too. If this divided by x minus 2 gives me x squared plus 2x minus 2, that means x minus 2 times x squared plus 2x minus 2 is equal to my original, right? That's what that means. So this does factor to that. Now the trinomial here does not factor. Okay, we'd be done, but we could solve this using the quadratic formula, couldn't we? So sometimes things factor, you don't see it ahead of time. It's kind of like asking yourself, is number 1023, is that divisible by something? Turns out what it is, but it's sometimes hard to see if it's a prime number or not, and whether or not something factors. So it does. So we're going to discover the way in which a lot of things factor. So let's flip it over to right here. We'll try a much more complicated one. X to the third plus 4x squared minus 2 divided by 2x plus 1. Have to put my 0x in place. Minus 2. What do I multiply 2x by to get x to the third? 1/2 x squared, right? Oh, you didn't like that, did you? All of a sudden fractions come in and Like you just like anger. Arr. Puts me in a bad mood. It's already in a bad mood, Mr. Guns. Now you do fractions. Oh, well. So, hey, don't do that. Smartboard got angry. All right, we got a 1/2 x squared. 1/2 x squared times 2x, x cubed. 1/2 x squared times 1, 1/2 x squared. Okay, notice how the front term always goes away. That's because you ask yourself, what do you multiply that by to get that? That's why it always goes away. That's what we're trying to do. That's the goal. So we can kind of get rid of all those pieces and pare this down in size. What is 4x squared minus 1/2 x squared? 3.5 written as 7/2, right? 7/2 x squared plus 0x. What do you multiply? We know we're going to have an x, right? X times x is x squared. What do you multiply 2 by to get 7/2? 7/4, right? Like, because 2 times what is equal to 7/2? How do you get rid of the 2? You multiply by a half. If you multiply both sides by a half, you get 7/4. So we have 7/4 x. Let's multiply 7/4 x through. 7/4 x times 2x. 7/2 x squared. Right? 14 halves, or 14, yeah, so, yeah. 14/4 is 7/2. 7/4 times 1. 7/4. I subtract, I get a negative 7/4 x. So you have a 2x and a negative 7/4 x, so I'm not going to need an x here. But 2 times what is negative 7/4? Up 2 times what is negative 7/4? Well, if you multiply both sides by a half, we get negative 7/8. So negative 7/8. Negative 7/8 times 2x is my negative 7/4x. Then minus 7/8. Subtract. What is negative 2 minus a negative 7/8? That would be negative 2, so negative 16/8, right? And then minus the negatives will be plus 7/8 gives me. Yeah, so obviously we have fractions, but what else do we have in this problem that comes up? A remainder. Now back at grade school, we would write R, meaning remainder, but we don't do that with polynomials. And so I'm going to teach you now in letter D. You're going to do letter D on your own, no fractions. Go ahead and do long division. Make sure you put in your zeros. And let's see if we come up with the correct remainder. And then I'm going to teach you what to do with the remainder. I'll also teach you how to find the remainder before you even start the problem. So yeah, do your best. Okay, that's what you should come up with. X to the third plus x squared minus 3x minus 3. You have a remainder of negative 1. Now, let's be honest. Raise your hand if you came up with a different remainder, something other than negative 1. Nobody. 1. Okay, you're the only one. You also have courage. Thank you. So about, I would say 2/3 of the class came up with a number different than negative 1 during third hour. Here's how you can confirm that, in fact, the remainder is exactly negative 1 ahead of time. And it is the remainder theorem. And the remainder theorem says this. If you want to know what your remainder is, simply take the solution to x minus 1. What's the solution to x minus 1? 1. And plug it into your original polynomial. What's 1 to the 4th? 1. Minus 4 plus 2. Every time you can check your remainder by simply plugging it in. Is that nice? Pretty sweet. And so the remainder theorem is a very important part of making algebra work, and that's something that we want to check. How do we write it? Well, before I took 6 and I divided it into 1042, and we got 173 with a remainder of 4. Well, there's a couple ways to write that. You could write 173 with a remainder of 4, or you could write it as 173 and 4 over 6, or 2/3. But you could also write 173 plus 4 over 6. I mean, that's what that means, right? So what you do with a polynomial is you write plus the remainder over the divisor. So plus the remainder plus -1, so -1 over, what's the divisor? X minus 1. So that's the way we write our finished product. And that's important because as we graph this, we actually come up with a reciprocal function that's undefined at 1. So it's important to write it like that. It has characteristics that are important. So that's your introduction to law and division. I actually don't give you any problems in an assignment over it. We just do it, and then I do give you some in a study guide. We got more important things to do today, and that is to move on to synthetic division, and then the rational roots theorem, which is totally awesome and amazing in every way. So it's a big day. So we are now going to do synthetic division, and synthetic division simply goes like this. Instead of doing law and division, we can kind of do it a shorter way. It works out really nice. What is the solution to x minus 1? So I put that in a little corner box. Then I list all my coefficients. What are my coefficients in the polynomial I'm dividing? 1, -4, 2, and 1. Draw a line underneath, and then I put another little box over there. That's for my remainder. First rule is we drop down the first number. First number is 1. So I put that down in its place, and then I multiply and add. So 1 times 1 is -4 plus 1. 1 times -3, and 2 plus -3. I'm adding, so I'm multiplying and adding, multiplying. So 1 times -3, give me -3. 2 plus -3, -1. 1 times -1, -1. 1 plus -1, 0. So did it divide evenly? Yes, it divided evenly. So therefore, what we have is this as our answer. So if this is the remainder, this would be the constant. That is the coefficient for the x term. This is the coefficient for the x squared term. So your final answer is x squared minus 3x minus 1, and you have no remainder. Better than law and division, right? Okay, you do B on your own. Go. Okay, so -15 should be your remainder, so therefore this is your constant. X squared, this is x to the third, so 4x to the third plus 4 minus 15 over your divisor, x plus 2. How about that? Not bad? Okay. Let's try when it involves fractions. What is our solution to 4x minus 1? A fourth. 4, -8, 12, and 3. Drop down the 4. 4 times a fourth. Get -7. -7 over 4. Oh no, more fraction. Got to convert 12 to fourths. 48 fourths. 48 fourths and -7 fourths. 41 fourths multiplied by 1/4. 41 sixteenths. Oh no. How do I convert 3 to 16ths? 48 sixteenths, right? So 48 sixteenths and 41 sixteenths. 89 sixteenths. A lot better than dealing with the long division, isn't it? So here's another indication as well. If you wonder what to start with your first coefficient, if you take a cubic or a third degree and divide it by a first degree, you're going to come up with a second degree. So we know we have a 4x squared minus 7x plus 41 over 4, then plus 89 over 16. And now I have to divide that by 4x minus 1 over 1. Well, when you multiply by the reciprocal, you just end up with 4x minus 1 in the denominator. So you try D on your own. You're so smart. You get 156? There you go. Okay, synthetic division, no big deal, right? So now we get to the purpose for which this is used, and that is the rational roots theorem. We want to be able to find all the solutions to polynomials that are much larger than what we did yesterday and that aren't so easily factored. And so there's this great theorem. It is beautiful. It works out great for us. It says if we have a polynomial of this form, and what you need to notice about the form is p of x, it's a function. The power decreases by 1 every time. So like x to the fourth, x to the third, x squared, so on and so forth. And really the important coefficients are the first one. So this is your lead coefficient. And then your very last one at the end, a sub 0, would be your constant. So if you ever see this notation in a book, that's just expanded form for writing a polynomial. And so let p of x be a polynomial of that form where a sub n, the lead coefficient, has factors. Meaning, for example, let's say it was 12. What are factors of 12? 3, 4, 6, 2, 1, 12, and positives and negatives, right? So has factors of q. And a sub 0, the very last term, the constant, has factors of p. If p of x, if the polynomial has any roots that are rational, what does it mean to be rational? X squared minus 2, does it have solutions that are rational or irrational? Irrational. They are positive and negative square root of 2, correct? How about x squared minus 1 equals 0? Are those solutions rational or irrational? Rational. And you could have fractions as well, correct? So that's what it means. If it has rational solutions, they are of the form p over q plus or minus. So what that tells us is we may see something that we don't know how to factor, but we might be able to make educated guesses on what some of the solutions are, and at that point be able to actually come up with our factored form and then be able to graph it accordingly. So please look at your first example. We're going to do 2 of these, and that's going to be it for the day. We want to be able to find these solutions. X to the third minus 7x minus 3. Now again, the solution for a cubic is about a full page and a half in length. It's very difficult to solve unless it has rational solutions. Then we got a good shot at getting it. First of all, what's the degree of this polynomial? 3. It doesn't factor, does it? So then we have to use the rational roots theorem. Rational roots theorem says find the p's. P's are factors of the n, which are 1, 6, 3, and 2. Sure. Q's are factors of the lead coefficient. The lead coefficient is 1, so your Q's are 1. So your choices for your solutions are your P's divided by your Q's. So I take each of my P's divided by each of my Q's. So 1 over 1 is 1, and I have to list the positive and the negative. Also, plus or minus 2, plus or minus 3, and plus or minus 6. So pretty easy to list those, isn't it? Fortunately, we have this great theorem called the remainder theorem that I just mentioned briefly earlier, and that says if we want to know if a binomial divides evenly, we simply plug in the solution and see what we get. So we want to see if one of these works. Let's just plug them in. You plug in 1. What's 1 minus 7? Minus 6. So did that work? No. Let's try negative 1. Negative 1 to the third. Negative 7 times negative 1. Does that work? Yay. So if negative 1 is a solution, what binomial divides evenly into the polynomial? It's plus 1. So it turns out it does factor. That's the front part of the factor. And then I'm going to have a quadratic behind it. We'll figure out what that factor is by simply using synthetic division. 1, 0, negative 7, negative 6. Drop my 1, negative 1. So, lo and behold, x to the third minus 7x minus 6 does factor. It factors to x squared minus x minus 6 times x plus 1. We couldn't see it. We're not intelligent enough to see it, but we could at least make guesses and go from there. Now, does this factor? Yeah, to what? So what are my solutions? Oh, I did that second hour, or third hour as well. 3, negative 2, and negative 1. Could we graph it? No, we even know how to graph it, don't we? If I take this and divide it by x plus 1, then I come up with that. So, all right, let's try one more together, okay? Let's try number 2. X to the third plus 3x squared minus 4. What degree? Third degree. What are my p's? 1, 2, and 4. What are my q's? 1. So what are my choices? What do you want to plug in? 1. What's 1 plus 3? Drag. 1 plus 3 is 4, minus 4. 0, great, 1 worked. If 1 worked, what's the factor? X minus 1 is the factor. So it does factor. It factors to x squared plus 4x plus 4 times that x minus 1 that we found as its original factor. So it's x plus 2 quantity squared. So what are the solutions? If we graph it, what type of solution do we have at negative 2? Double root. So it makes a parabola type shape. So all of a sudden, learning to graph some of these things and find their solutions is not that big of a deal. You can do it pretty quickly, pretty efficiently, pretty effectively. Rational Roots theorem, amazing. Almost seems like magic, doesn't it? Better than magic. Like, if you had a choice on a Friday night to go to a magic show or go to a Rational Roots theorem exposition, like you might say, hey, let's turn on YouTube and find a video by Mr. Jens on Rational Roots theorem. All right, you need an assignment. You need an assignment. You need to practice. No, no. There you go. 3.3, page 287, numbers 5 through 13, odd. Find the solutions and graph them. We'll continue on the rational roots theorem, doing harder problems on Monday. And that will have taken us through 3.1, 3.2, and 3.3 of our text. So you're not looking at tests next week, but you are looking at tests the following week. So we'll get through the material. If you plan on retaking that last test, I would encourage you to do so before Christmas. Otherwise, you will remember nothing.